Now we're talking about measures of variation. Basically, we're going to ask, how spread out is the data? So before we do that though, let's review measures of central tendency. So when we did measures of central tendency, you were looking for a job. And you compared Widgets Incorporated to Apps R Us. And you found the means and you found the medians. And because of those pesky outliers in Widgets Inc., we realized that the median was the most accurate measure of central tendency, and we decided that Apps R Us was going to be the best job because that was most likely the highest salary. Here's the thing. You got fired from Apps R Us. I don't know what you did, but you got fired. So it's time to get another job. Now, this statistics thing is really cool. So, armed with this statistical knowledge, you look up the starting salaries for the statistics teachers at 2 different high schools in the area, okay? So we've got school A and we've got school B. You know the drill, right? Like, you quickly find both the mean and the median for each school. So the means, well, they're the same. Okay, and the medians, they're also the same. So now what do? You go back to your stats buddy and like, what do? He says, check the variation. In other words, how far do all the data points stray from that measure of central tendency? Okay, so to begin with, you sort the salaries from lowest to highest. Then you subtract the lowest salary from the highest salary, and this gives you what we call the range. So the range for school A is $10,000. The range for school B is $35,000. So you can see the range for school B, that's a lot higher. At school A, well, the highest and lowest salaries, they aren't too far from the middle. But in school B, you could get a really low salary, or you could get a really high salary. So that's something you need to think about. Here's the thing though, we've only considered like the extreme salaries of each school when we found the range. So what about the other salaries? How far from the middle are they? All right, so to answer that question, we need to look at how far each salary is from the middle. So we're just gonna take school A first, take the salaries of school A, and we found the mean, and the mean was $41,500. Okay, now this symbol right here, we call that mu. Mu is the symbol for a population mean. Kind of sounds like a French cow. Mu. Anywho, so we're gonna take each of the salaries and subtract the mean, okay? So subtract the mean from each salaries. Now we know the difference of each. We could find the average distance of each of the salaries from the middle. So we add them all up, divide by 10, that's how many salaries we have, and we get the average difference is, 0. Well, that doesn't make any sense because none of those numbers are anywhere near 0. Here's the thing. Some of them are positive and some of them are negative. And so those positive and negative numbers, they cancel each other out. So we have to deal with those negative numbers. Remember, a negative times a negative is a positive. So if we take each of those numbers and square them, all the negatives will go away. So we'll take x minus the mean, square all those numbers, okay? Now we can find an average because we have all positive numbers. So we add all those numbers up, and this is called a sum of squares, okay? Now we're gonna take the sum of squares and divide it by the number of salaries. That's what N stands for, the number of data points you have. Okay, now this is called sigma squared, okay? Sigma squared, and this is the variance. Now, so we got 88,500,000 divided by 10, and then we get the variance is $8,850,000. That's a huge number. That can't be like the average from the mean. Because remember, here's the thing. We had to square all those numbers to get rid of the negatives. So now we have to go undo that square. by taking the square root. We're going to take the square root of the variance, and that gives us sigma, not sigma squared now, just sigma equals about $3,000. That makes more sense. That's called the standard deviation. Or you could also think about it as the average distance from the mean. Okay, standard deviation. Let's walk this through for school B. So we'll take each of the salaries for school B, subtract the mean, which remember is the same from school A, subtract the mean from each of the salaries, square them to get rid of the negatives, okay? Add those up, that's the sum of squares. Divide that by the number of salaries, which is 10. Then we get our variance, which is, wow, 102,500,000. But we have to take the square root of that. So now we get our standard deviation is 10,124. I realize I went through that really fast. You can rewind the video or pause it at any time. Okay, so where are we here? Standard deviation is 10,124. We have a much better picture now of school A versus school B because we know the range for school A is 10,000. Range for school B is 35,000. That only took into account the extreme values, so then we took each of the values to see how far they were from the middle. So the average distance from the middle from each of those values for school A, about $3,000. For school B, about $10,000. The good news is you don't have to do this by hand every time, although it's good to know how to do it by hand. But you can use a graphing calculator. So to find the standard deviation on a graphing calculator, we're going to go stat edit. Okay, we're going to put all the numbers, all the salaries, we're going to do one list at a time into list one. Then you're going to go back to stat calc, hit one variable stats. For list, you hit list one, frequency list, make sure it's blank. And then there we go. Right there is the standard deviation. All right. Now, here's a fun fact, and it's called the empirical rule. So let's say you have a symmetrical distribution, a bell-shaped distribution, which means right in the middle of that is your mean. Okay, if you go one standard deviation lower and one standard deviation higher, then you actually know that you have just about 68% of the data. That works for all these symmetrical curves. If you go 2 standard deviations from the mean, then you get 95% of the data. If you go 3 standard deviations from the mean, then you end up with 99.7% of the data. That's kind of cool. Okay, so let's see the empirical rule in practice. Okay, let's say the mean selling price of homes in Colorado Springs is $350,000 with a standard deviation of $45,000. Here's the question. We're assuming it's bell-shaped, okay? 68% of the homes would sell between which 2 values? You know that 68%, if you take the mean and subtract a standard deviation, and you take the mean and add a standard deviation, you'll get 68% of the data. So we'll take $350,000 minus $45,000, $350,000 plus $45,000, and we know that 68% of the homes are going to sell between $305,000 and $395,000. Works out really neat. Okay, one more. If 200 homes were sampled, what percentage would sell between $260,000 and $440,000? If you look at those two, we could see that $260,000, that's 2 standard deviations below the mean. $440,000, that's 2 standard deviations above the mean. So if you have 2 standard deviations below and above the mean, that's 95% of the data. So 95% of 200 homes, you know that 190 homes would sell between $260,000 and $440,000. One more cool thing about the empirical rule is that it helps us to define unusual values. And unusual values are any values that lie outside those plus or minus 2 standard deviations from the mean. So anything below that 95% and anything above, those are considered statistically unusual values. All right, so Those are measures of variations. And they ask us, or they help us answer, how spread out is the data? We can look at the range. We can look at the variance. Take the square root of the variance, we get the standard deviation. We get a much, much better picture of what the data really looks like. Thanks for being here.